Hello and welcome to Lesson 1 of Unit 10, Graphing Quadratics in All Forms. Lesson 1 today is going to review what we've seen with standard form and vertex form, and then also bringing in what we talked about in Unit 9b, which was finding solutions, which we learned would be our x-intercepts. So, I'm just going to read it. At this point, you are expected to know how to solve quadratics by factoring and square rooting. You are also expected to know how to graph quadratics in standard form and vertex form. Let's tie these examples together. So our example 1, we are given y equals x squared minus 4x minus 5. This equation is in standard form, because that is y equals ax squared plus bx plus c. And so what it does is it gives us our y-intercept. So this is step 1. Our y-intercept is our c value, which is in this case -5. We can then find our axis of symmetry, which is our formula. So that's that -b all over 2a, x equals, because it's creating an equation. And so we get -b all over -b over 2a. And so let's solve this by hand. So we get 4 over 2, which is 2. And so how we find our vertex is we take that value and we plug it in. So y equals 2 squared minus 4 times 2 minus 5. I'm going to do it by hand because it's always good to practice it. So we get 4 minus 8 minus 5, which is -9. We're not going to use the table. We can do this by hand. And so let's graph our y-intercept, which is at -5. Our axis of symmetry, which is at x equals 2. And our vertex, which is at -9. So our vertex is actually 2, -9. That's really what our vertex is. And our axis of symmetry is actually x equals 2. Now we can reflect our point over, and how do we get more points? Well, since our a value is 1, we can go over 1, up 1, and that creates our graph. And so when we connect our points, our graph looks like this. And so, our domain, as always, is -infinity to infinity. Our range is going to be a bracket. It's that y value, so -9 to infinity. Increasing and decreasing. Increasing, where's our graph going up? We're going up from 2 to infinity. Where's our graph going down? Right here, it's going down. And so that's -infinity to 2 within parentheses. Remember, we always use parentheses when we are doing increasing and decreasing values. So what are the x-intercepts? Well, we can kind of figure it out. I'm saying my graph is pretty accurate. And we can say, oh, we cross at -1 and +5. Well, we can also do that by doing, okay, 1, 1, 2, 4, 3, 9 gives us that point, and we can reflect it over. So we can use our perfect squares to get more points. Well, what we could do instead is we can actually solve for x. And so the best method to solve this is to factor, and we can see that because there are two numbers that multiply to get -5 and add to get -4, 5 and 1. And so what we get is x minus 5, x plus 1 equals 0, and so x equals +5 and -1. Oh, look at that. And so with function notation, you would be asked to find the zeros of the function, and given f of x equals x squared minus 4x minus 5 instead of y equals, but they work in the exact same way. And so what do you notice about the solutions of the equation part 2? For the graph in part 1, we talked about this. The solutions are the x-intercepts. And we've talked about this a lot. And We talked about this with our discriminant. Not all x-intercepts are nice rational integers like this. And so we can find the x-intercepts for this problem. So I'm just going to cross out that y equals. Now, we can't factor it because there's no two numbers that multiply to get 9 and add to get -4. And so we can use the quadratic formula or we can complete the square. I think completing the square is a little bit easier. So x squared minus 4x plus something equals 9 plus that same something. B divided by 2 is -2. And -2 squared is 4. So 9 plus 4 is 13. When we I know there's not a lot of room, but when we square root both sides, we get x minus 2 equals plus or minus the square root of 13. And we get x equals 2 plus or minus the square root of 13. And what happens, so those are irrational, but we can actually, they are still real. We can do 2 plus the square root of 13 and 2 minus the square root of 13. So in our calculator, we would literally do 2 plus second x squared 13, and we would get 5.605, so 5.61. Now we can do the same thing and subtract them, and we would get -1.61. Now it's just a coincidence that they're both 6.1, but that's the idea. Okay, but they still exist. They're real solutions. Okay. Next page, here we go. So example 2, we are given this. We are given this in vertex form, which is y equals a times x minus h squared plus k. Okay, and so vertex form gives us our vertex. Now we got to remember it's opposite, same. Then it gives us our axis of symmetry. Remember, the axis of symmetry is the x value of our vertex. And we can find our y-intercept by just plugging in 0 for x and solving. So we get 3 squared is 9, -9 plus 4 is -5. And so we can graph all these pieces of information. So we've got -3, +4, line through the equals, there's our axis of symmetry. My y-intercept is -5. I can reflect it over, which I didn't reflect it over the right amount. There we go. And now we can use our a value, which is -1. So what that's going to do is usually we go 1, 1. What we're going to now do is go over 1, down 1, reflect it over. Over 2, down 4, reflect it over. And that creates our graph. And so voila, there's our graph. And so our domain, as always, is -infinity to infinity, but our range is -infinity to 4 with a bracket because we hit at 4. And the reason we have flipped our range is because that we have that reflection over the x-axis. And so now looking, we're increasing on the other side. We're going up from -infinity to, -3 with the parenthesis. And we are decreasing, so where's our graph going? Down here, and so we're decreasing from -3 to +infinity. And because I did so many points, we can actually see that our x-intercepts, where we cross our x-axis, are at -5 and -1. And so, again, if we wanted to solve this problem, the best method to solve, since it's vertex form, is solving with square roots. And so what we're going to do is we're going to kind of replace that with, with 0 and then solve. So I'm going to subtract 4 from both sides. divide both sides by -1 because, again, we're trying to isolate our square term. So we get x plus 3 squared equals 4, and then we square root both sides. Now, when we square root a number, we get that plus minus, and plus minus, and the square root of 4 is 2, so the square root goes away. And so when we subtract 3, we get x equals -3 plus or minus 2, which will give us -3 minus 2, which is -5, and -3 plus 2, which is -1. Look at that. So, again, solutions are the x-intercepts. Woo! Okay, so again, not all x-intercepts are nice rational solutions. So for example, if we take this problem, we set it equal to 0. When we add 5, when we isolate that squared term, and when we square root both sides, 5 is not a perfect square, and so we get that plus or minus 5. And then, when we subtract 3, we would get x equals -3 plus or minus the square root of 5. There's still two real rational, irrational. They're real, but they're irrational. And so when we plug it into our calculator, we would get -0.76 and -5.24. So those would be our x-intercepts. They're irrational, but they're still real. But let's look at this problem. Let's set it equal to 0. Now when we subtract 5, we get this equals to -5. And then when we square root, we have the square root of a negative, so we get no solution, which means that there are no x-intercepts. And that ties in with our discriminant that we talked about in our previous unit. So, conclusion, the x-intercepts of the graph of an equation are the solutions of the equation, or zeros, if written as a function f of x. If they exist at all, the x-intercepts could be rational or irrational. Again, rational is like 5 and 1/2, or irrational, which is like 5 plus or minus the square root of 3. They're still real, they still exist, they're just not nice numbers. And so this is going to kind of bring everything together. Here we go. We're going to just do this first piece. So here we go. So our axis of symmetry when we're given vertex form. So actually I'm going to write, this is your first step, your vertex. That is h comma k, where h is the opposite and k is the same. Then we can find our axis of symmetry. This is x equals h. Our x-intercepts, you can choose. This is like number 3 and number 4. They're interchangeable, your choice. Your x-intercepts, that's where we take your equation. We set it equal to 0. So 0 equals a times x minus h squared plus k. And solve for x. And then the y-intercept, that's where we plug in 0 for y. Plug in 0 for y. Oopsies, for x. Whoa. For x-intercepts, that's what we plug in 0 for y. So we get y equals a times 0 minus h squared plus k. From our concavity, if A is positive, it's concave up, and so our graph will look like this. It's a smiley face. And if it's a negative A, that means we have a reflection, so that means that it's negative. So that means we're concave down, which means we have a reflection, so we're a sad face. And then finally, we have our vertical stretch and shrink. If A is greater than 1, we have a vertical stretch. by a scale factor of A. And then if A is between 0 and 1, we have a vertical shrink by a scale factor of A. So that just kind of brings everything together. So that's vertex form. And then standard form, which is on the next page. If you're given standard form, your first step is to find your y-intercept, because this is your C value. Then from there, I suggest doing your axis of symmetry, which is x equals negative b all over 2a. Your third step should be to find the vertex, which is you plug in the axis of symmetry for x. So f of your axis of symmetry equals your value, and so we get x comma y. And then from there, you find your x-intercepts. So again, that's where we solve for x. Or you can plug in 0 for y. So 0 equals ax squared plus bx plus c. And then our concavity and vertical stretch and shrink, these are all the same. If A is positive, it means it's concave up, which means it's a happy face. And then if A is negative, it means it's concave down, which means it's a sad face. And then finally, we have our vertical stretch and shrink. If A is greater than 1, it is a vertical stretch by a scale factor of A. And if it's between 0 and 1, remember, if it's less than 1, it means it's a reflection over the x-axis. It's a vertical shrink by a scale factor of A. And so that is everything. We will do the other two practice problems together in class, but come with your questions.